on green nanotechnology and sustainability by Dr. Kula Kamal Senapati from IIT Guwahati. Is an Indian chemist and scientific professional recognized for his contributions to chemical science, analytical expertise and research. He began his professional career as a scientific officer at the Indian Institute of Technology, Guwahati. He has conducted extensive research in nanotech materials, catalysts, green chemistry, bioactive compounds, and material chemistry during his PhD and subsequent research career. Dr. Senapati worked as a scientist in the Department of Biochemistry at the Toklai Tea Research Institute, where his research focused on tea biochemistry. He received the National Green Innovation Award, and one of his research work was featured in Nature India. He also had many publication books, which is authored by him. The Sixth Sense, further reflecting his commitment to knowledge, dissemination, and personal growth. It is our honor to invite Sir and to kindly deliver your lecture. Over to you, sir.
Thank you, ma'am, for your kind introduction. Respected principal of this college, respected dignitaries, respected professor of Guwahati University. It is my pleasure to give a lecture in nanotechnology and sustainability. In fact, this is a field where cutting-edge research means its responsibility towards our nature as well as our future generation. Philosophically, it gives us the possibilities of being a human, not only just human beings. Nanotechnology obviously gives us a tremendous power at the smallest possible scale. So in this scale, with this power to see green nanotechnology makes us the possibility how wisely, safely and sustainably we can use this nanotechnology power. You see, the idea of nanotechnology actually came long back before its real scientific outcome took place. So it was in 1959. So a very renowned scientist. His name was Richard Feynman. He gave a visionary lectures at the California Institute of Technology. It was entitled "There is a plenty of room at the bottom: invitation to enter a new field of physics." He imagined smallest possible scale. So atom or molecule by molecule, material can be designed and developed. At that time there was no such tool, and that's why it sounded to be quite impossible to work with this very smallest possible scale. For the first time, the word nanotechnology was used by a Japanese scientist, Norio Taniguchi. So while he was working at the very small scale. But till 1980, so there were no such nanoparticle to study the nanoscale device. So it was in 1980, scanning tunneling microscope and atomic force microscope came into existence. So in 1981, in scanning tunneling microscope, it got Nobel Prize. The discovery of C60 or fullerene is an allotrope of carbon, and then quantum dots, and then carbon nanotube. So he revolutionized the field of the nanotechnology. There will be in two parts about the scientific process of nanomaterials as well as its characterization technique and some application in green nanotechnology in sustainable development. Now in every sector nanotechnology have been realized. It is a part of material science or matter. So it has a huge potential. So it has unique features, it has unique properties and useful applications. So my first introduction with this scanning electron microscopy. So that was the fundamental things to get the morphology of the nanomaterial. Whatever you synthesize, you can see. See, from 1960 onwards to say 2000. So there was no such advancement in nanotechnology. But up from 2000 onwards, it has been tremendous development in every sector. But now, this time, actually you see it is the artificial intelligence, machine learning, robotics. So this has been popularized. And earlier, during that time when we started that work or before then 10 years back, so everyone put the words nano in their work. So that was a buzzword that time. So that was a fashionable when you work something and then use the term nano. But now in every sector, every field, it is quite integrated to our day-to-day life. Nanotechnology field is realized. So what we are doing in the smallest scale, 1 to 100 nanometer, so it is the nanotechnology. So you can manipulate the things at the nanoscale level. Roughly say in 1 dimension, 2 dimension or 3 dimension, maybe 1 to 100 nanometer. At the very smallest scale, so it has unique property it is completely different property from the bulk material due to quantum confinement effect, or whether it can be high surface to volume ratio, or whether it can be extraordinary stability, mechanical, thermal. So green nanotechnology actually encompasses the nanotechnology as well as the green chemistry principle. So it is the atom economy, atomicity, reusability, low toxicity, less toxic byproduct, this recyclability. So all these things are the basic principle of green chemistry, and green nanotechnology encompasses the nanotechnology as well as green chemistry. It was in 1989, two very renowned scientists, Warner and Annatis, postulated 12 principles. So it is widely adopted by worldwide. So now green nanotechnology has been applied in every energy sector, whether it can be energy consumption, whether it can be energy storage, whether it can be energy transmission, or whether in energy or other energy conversion processes. Nanometer is very small. So our human hair, you can see it is a 50,000 nanometer, one human hair size. In gold atom, if you align, 3 gold atom can give you a 1 nanometer scale, and 10 hydrogen atom give you the 1 nanometer scale. It is extremely small. Nowadays, through this scanning electron microscopy or atomic force microscopy, you can manipulate, you can design and develop atom by atom. So nanolithography is another very significant field in this area. You see in this scale where there are so many naturally occurring nanomaterials, as well as there are synthesized or prepared nanomaterials, nanoparticles, gold nanoparticles, polymeric nanoparticles, or fullerene nanotechnology. Within this decade, so many Nobel recognized work have been linked to the nanotechnology as well as to the environmental science. So one such work is MOF, metal organic framework. It is last year it got the Nobel Prize in that area. Another is very highly in every electronic sector. It has been widely used. That is the quantum dots. 2023 it got Nobel Prize in that area. Or it was started in 2016 in molecular medicine. So now it is the basic things of this robotic technology. So many things in this area have been well recognized, Nobel recognized as well, which is linked to the environmental science, nanotechnology, green nanotechnology. So once you come to this small size, definitely it gets tremendous energy. So with this energy, we can have this transformative power to change so many things, design so many devices. Yeah, if we go to physics, up to 20th centuries, all motions, molecular motions, microscopic motions or macroscopic motions, Newtonian mechanics were dominated. Basically, Newtonian mechanics, whether maybe is trajectory motion, whether it can be in microscopic motions. After that, later part of this 20th centuries, so new mechanics come, so there is quantum mechanics. So there are actually wave properties of the electron was considered, and then so many physical properties has been changed, whether it can be electromagnetic forces, tunneling effect, or quantum confinement. So this has changed the entire properties of the nanoparticles. Yeah, similarly in view of chemistry basically the bond formation and bond making processes. So all electrons are involved. So in that particular cases, whether it can be intermolecular cases, definitely you see changes of the structure, or if it is intramolecular, bonding, maybe hydrogen bonding, or maybe dipole interactions. All these things happens at the nanoscales. So this is the basics of the physics and chemistry where nanoparticles or nanomaterial came into existence, and it plays at this small scale. In material chemistry, that is very significant. Basically, the nanomaterial or nano device, it plays a role of the surface. So surface has the delocalized electrons. So this has the surface property. Once it is going down and smaller sizes, so it has the surface energy is very high. And definitely, so nanoparticle not only the size, shape also it matters, and it has the great impact in different applications. Yeah, definitely quantum dot. I already told in nanoscale it is energy is quantized, whether it can be in conduction band or it can be in valence band. And here in case of quantum dots, you can tune the size of the energy gap between the valence and conduction band. Accordingly, you can have different photocatalytic or any other catalytic properties of the material. Nanomaterial synthesize metal nanoparticles say. So same metal nanoparticle you can have different colors based on the shape and size. Here I am showing the zinc sulfide cap, cadmium selenide quantum dots. So this have in different shapes and sizes have a series of colors. So this is another aspect, and basically this is due to the surface plasmon effects of the delocalized electron over the surface of these metal nanoparticles. Carbon nanotube has very beautiful structure. It is a lot of carbon. We have the same conical structure, but if you see, it is very strong, stable. It is almost 100 times more stronger than the normal steel and 10 times lighter. So it has tremendous strength and properties.
If you come to green nanotechnology, so green nanotechnology finds application in different sectors. Alright, in medicine, whether it can be targeted drug delivery or